The Cosmic Shadow. Unveiling the Mystery of Dark Matter. Our universe is a vast and enigmatic expanse. It is filled with billions upon billions of galaxies, each containing countless stars. But what we see, the brilliant stars and glowing galaxies, is only a small fraction of what is actually there. Lurking in the shadows is a mysterious substance known as dark matter. It is invisible to our telescopes and undetectable by any instrument we have ever created. Yet, its gravitational influence dominates the cosmos. Dark matter is a truly perplexing enigma. It does not emit, absorb, or reflect light, making it completely invisible to us. It's like a phantom, casting a gravitational shadow on the universe, but remaining hidden from our view. Imagine a cosmic dance floor where we can only see some of the dancers. We can tell there are others present by how the visible dancers move, even though we can't see their partners. This is the case with dark matter. We can infer its presence by its effects on the visible universe. It's a bit like trying to understand the wind by watching how it moves leaves on a tree. We may not see the wind itself, but we can see its impact on the world around us. Gravitational clues, how we know it's out there. So how do we know dark matter exists if we can't see it? The answer lies in its gravitational influence. Just like the Earth orbits the Sun due to gravity, stars within a galaxy orbit the galaxy's center. However, when astronomers measured the speed of these stars, they found something astonishing. The stars were moving much faster than they should have been based on the visible matter alone. This discrepancy between the observed rotation of galaxies and the amount of visible matter they contain was one of the first clues to the existence of dark matter. If the visible matter was all there was, galaxies would fly apart because the gravitational pull of the stars wouldn't be strong enough to hold them together. This realization led scientists to propose the existence of a hidden mass, a dark matter that provides the extra gravity needed to keep galaxies intact. Further evidence for dark matter comes from the observation of galaxy clusters. These massive structures are the largest known gravitationally bound objects in the universe. By studying how light bends as it passes by these clusters, a phenomenon known as gravitational lensing, astronomers can map the distribution of mass within them. These studies reveal that the mass of galaxy clusters far exceeds the mass of their visible components, again indicating the presence of a significant amount of unseen matter. Spiraling galaxies and colliding clusters, evidence for the unseen. One of the most compelling pieces of evidence for dark matter comes from the study of galaxy rotation curves. These curves plot the orbital speed of stars in a galaxy as a function of their distance from the galactic center. According to Newtonian physics, the orbital speed of stars should decrease with increasing distance from the center, just as the planets in our solar system orbit the Sun at slower speeds the farther out they are. However, observations of spiral galaxies reveal a very different picture. Instead of decreasing, the orbital speed of stars remains relatively constant, or even increases with distance from the center. This unexpected behavior suggests that the mass of a galaxy is not concentrated in its center, as we might expect from the distribution of visible matter. Instead, it implies the existence of a halo of invisible matter, extending far beyond the visible disk of the galaxy. This halo of dark matter provides the additional gravitational pull needed to explain the observed rotation curves. Another striking piece of evidence for dark matter comes from the observation of colliding galaxy clusters, such as the Bullet Cluster. This cluster consists of two galaxy clusters that have collided head-on at incredible speeds. During the collision, the visible matter in the clusters, mostly in the form of hot gas, interacted and slowed down, lagging behind the collision. However, observations of gravitational lensing revealed that the majority of the mass in the clusters, presumably in the form of dark matter, continued on its trajectory unimpeded. The elusive nature of dark matter, why we can't touch it. The fact that dark matter doesn't interact with light is just the tip of the iceberg. It also doesn't seem to interact with ordinary matter or even itself in any significant way except through gravity. This elusiveness is what makes dark matter so difficult to detect and study. It passes right through us, through the Earth, and through everything else as if it were a ghost. But why can't we touch dark matter? The answer lies in the fundamental forces of nature. The universe is governed by four known forces: gravity, electromagnetism, and the strong and weak nuclear forces. Ordinary matter interacts through all of these forces, but dark matter seems to only interact through gravity. It's like trying to catch a shadow, it simply passes through any net we try to cast. This lack of interaction with electromagnetism is particularly significant. It means that dark matter doesn't emit, absorb, or reflect light, rendering it invisible to our telescopes. It also means that it doesn't experience the electromagnetic force that holds atoms together. This is why dark matter can pass through ordinary matter as if it weren't even there.